Hello, and welcome to our spectrophotometer video. As with any good lab, the best place to start is with the proper attire. The spectrophotometer is an important tool used in this lab to help determine the identity of an unknown solution and its concentration, but the data that it produces has to be processed in order to find this information. This is where the Beer-Lambert law is needed. This law is an equation used to calculate the absorbance of a solution, where A is the absorbance, which doesn't have any units, and epsilon is the molar extinction coefficient, but more commonly it's referred to as the molar absorptivity, and it has units of molarity per centimeter. C is the concentration in molarity, and finally L is the path length, or the width of the cuvette in centimeters. Calculating the absorption using this formula depends on the assumption of two different factors. The first is that the absorbance is directly proportional to the path length of the sample, or the width of the cuvette, and two, the absorbance is directly proportional to the concentration of the sample. After 3 serial dilutions are made from the original solution, they are each transferred to a cuvette, and water is added until the fill line of the cuvette is reached. Alright, give us a nice thumbs up. A cuvette of plain water is also needed, as this is used to zero out the spectrophotometer.
After inserting the blank solution in the spectrophotometer, make sure to close the lid and then zero it out.
All the serial dilutions made earlier are now measured using the spectrophotometer.
I can squeeze this in.
The notebook shown here is an example of data recorded from a spectrophotometer run. As you can see, both the stock and all 3 dilutions have recorded values for the absorbance and the wavelength in nanometers.
The solutions in this lab are allowed to be poured down the sink. Don't forget to clean up your station and wash all of the glassware you used for this experiment.